Hello there once again. This is Al, and this is the next lesson, I guess, number 87 in this series. For this section, actually, I just wanted to briefly try and go over all this Unicode and code pages and UTF-8 and all that, and try to give you a sense of how things were, back before Unicode became a big deal. And I was looking through some old code here, just trying to find some of the craziness that I had to go through. I found some stuff in this file. See, again, like I told you, we had to take care of cases in both Western and Eastern Europe, which use different code pages for their, 256 byte character mapping. So I had things like code page helpers, and this is some kind of optimization thing. So generally, if you didn't know what to do with a key, and you found its Unicode value, and you had a code page, you might be able to map it to a code page index. And that's what this particular function attempts to do. If it's less than 100, that doesn't mean that it's going to have a mapping. Here I'm going through the ranges where there is no translation, so like 23 equals to 23, and seeing if it's in one of those ranges. If that's true, no problem. Then there are the untranslated ranges, which I step through and try and find a match. If I can't find a match, then just give up. Then there's the problem of how do you change something to uppercase. I'll have to use these locale versions of everything. If it's ASCII, I use the current locale. If it's not ASCII, and if the current code page is 1252, then I can check if it's between little a and a little. That's Z. That's Z in Europe. Western Europe, anyway. 1252. Two lower, same kind of deal. So now there's those problems. Then there's dealing with the keyboard itself, which can generate all kinds of weird input. Now, I was just looking through here at some of the keyboard handling. Let's see now, would it be, was it in here? On key. Delete, escape. On key is pretty easy. It's key down. It's key up and key down where you have the problems. Let's see now. What was I looking before? Somewhere in here. Left, right, escape. dots. I don't know what the dots are. On mouse, on draw, and update. Somewhere eventually. Right at the end there. We must not be there. Oh, GK app. That's what it was. Yeah. Now see, there was also the problem of joystick, but actually that's not so bad. Joystick only does 4 things. Checking if a key is down, depending on whether or not you're ignoring the focus. I forget what this does. This VK to scan EX is an important function that you have that you should remember if you have a handle to a keyboard layout. A keyboard layout is a funny thing. See, like this, I live in Cambodia and I bought this computer here, and see, there's a keyboard layout for typing. If I wanted to, I could change my keyboard to emit character codes for these characters, right? And actually, the Cambodian language only received its slot in the Unicode code space very recently, just a few years ago. But before that, they were just using a hack, using I think a Thai layout, and then just change the font. But now they have their own Unicode slot, and then gets key state. Now at some point, the keys have to be handled. Posting a key, mouse events, joystick. It would have to be at the bottom, of course. Everyone I look for it at the bottom. Key car. We were using this graphics engine called Sexy App Framework. Well, that was by PopCap Games, I think. They have their own graphics engine, and I incorporated theirs into ours. Now, so I got to sort of mix what they think is going on with what I know is going on. Now I know I might know the keyboard language is English, and in that case, if the control key is down, I have to fake a VK scan output. For all characters, including C, Control C not being special. So I add these extra flags to the character. Now I'm back to this virtual key to scan, depending on the keyboard layout. And then, now if the key is not down, you can check to see if See, this is on a key card. Now the key should be down. The character corresponding to that. The key corresponding to that character should be down, but it won't always be, because you can always do that Alt 1, 2, 3 stuff, right? So now, what am I doing? Now I'm checking to see if it's valid for the current code page. Now those things would have. Now this is actually incorrect. I didn't know at that point that those alt codes produce code page 437 keys. I thought they produced 1252 keys. So this is actually incorrect. So some things probably didn't work. And I would have got a lot of these traces. Now there's key down. Okay. Now I got to get the state of the entire keyboard, and check to see I'm checking to see now if the numeric keypad keys are being pressed, and when that's happening, a virtual key code gets produced somehow, which I can somehow translate using the OEM scan code into a Unicode key code, using this to Unicode EX. Okay, and now I'm trying to remap that with a code page to a key. You can see how complicated. It's a great big complicated mess. Okay. You thought the bias had taken care of everything, but it hasn't. Okay, well, now I was looking back at some of these documents here. Now, this here book, Programming Windows by Charles Petzold, was the Windows programming Bible for years and years and years. And one of the first things he talks about is Unicode. Oh, here, yeah. Now, you're talking about these standards. Originally, the standard was ASCII. There are two things that I always get confused. One is ANSI, A-N-S-I, and the other is ASCII, A-S-C-I-I, okay, but it's actually, okay, ASCII means the American Standard Code for Information Exchange. So the A stands for American, S for Standard, blah, blah, blah. Okay, now that's the ASCII character set. Now, then along comes ANSI somewhere. Where's ANSI? Here, the ANSI character set. Now what does ANSI stand for? That's the American National Standard for Information Processing. It's basically the same, except one is national standard and the other one is just standard. So one is American National and one is American. So they're the same. It's just a different committee. Okay, so now then they came up with their standard. But then there was still Japan to worry about, right? Like here he says Chinese, Japanese, Korean, blah blah blah. But like, why doesn't he list this word first? There was no Chinese market when this book was written. The big worry was Japan, because they were potentially going to start making their own hardware and standards and things, and the U.S. companies would be out of the market. That's why you see, in a lot of these, when you look up things to do with code pages and stuff, you find a lot of, like, even in this thing, where is it? Where's my thing? The local. And when you look at keyboard, which is, well, starts at 9, I guess. You don't have to look too far to start seeing things that look like Japanese. Okay, let's go to bias keyboard. Alright. What was the keyboard? Oh, 16. Somewhere, it's not going to take long. You're going to see something, and it's going to look Japanese. We'll start with check for keystroke. 21 and 16 and bias. Set disk. Equipment list. Joystick. You see keyboard anywhere? Okay, here's keyboard. I'm just getting unlucky because usually you hit on it right away. Oops. What's K plus, I wonder? Toshiba. Toshiba, is Toshiba Japanese? There's something that begins with a K. Well, Valetti. In any case, it's true. Japan was definitely a worry, not China. Okay, so here it is. Here's the answer. Unicode to the rescue, right? Basic problem we have here is that the world's languages simply cannot be represented in 256 codes. Previous solution involving code pages and DBCS, that's double byte character sequences. That was where you had single bytes and sometimes double bytes. It also didn't work out for some reason or other, or it was awkward. Okay, what's the real solution? Unicode, right? Try 16-bit stuff, and this ridiculously simple concept is the answer to all the problems. We have one code page for every single language in the world, and it's just a matter of deciding which language fits where. Are there any drawbacks to Unicode? Sure. Occupy twice as much memory. Well, it's not really. Who cares? Compression helps a lot. The worst thing is relatively unused. But you see now he's missing it, and he's missed the point. And a lot of people have missed the point. And a lot of people continue to miss the point. And the point is this. The point has to do with the craziness, the insanity bit that I keep telling you about. You know, land of insanity, everything's backwards, things are backwards. A 16-bit value, okay, is not a unique number. It depends on the hardware. Okay? Now, that's why you see this sort of thing. Get a file open somewhere. CTPT by Intel doc. Okay, here's our Intel doc. Doesn't draw correctly because it's using the wrong code page. But whatever. If I open this up with a different editor, this has more stuff talking about encoding. Okay. Now, there's Unicode, right? Unicode, as was just explained by Charles Fessel, the guru, means that everything is 2 bytes. Every character is a 16-bit value. So, if your strings are double byte wide-card values, if you want to save your string to a file, it's just a matter of memcopy. Correct? Wrong. Wrong. You see, because the machines don't always work the same. You ever seen this word? Endian. Do you know what that word means? It actually has, it's not a made-up stupid word. It has a meaning. Little endian and big endian, and it's kind of a puzzle as to what it could possibly mean. Well, rather than let you puzzle about it, endian, little endian. Little and first, big endian. Big and first. Okay? That's all it means. So now a x86 computer is little endian because, as you've seen, how can I? Well, easy enough. Name LE little endian big endian dot text. Enter 100. No, sorry. RAX. Oh, let's see. I'll go 1122. Okay. And RBX 3344. Alright. Okay. And here's our memory. Okay. Move Well, I have an AX is already 1, 1. So move into DI 100. Move DI AX. Move add DI 2. Move DI BX. I'm going to trace through this. Trace. Okay. And if I put 4 in CX, clear out BX, I can write it out. Okay. And now, I changed my dirt in that. Oops. Here's our funny file. 4 bytes big. Where is it? Little end. Is it little endian or big endian? Well, we can only determine that by looking at it in binary. Binary. Okay, now remember it was 1122, right? So the little end of AX went first, and the big end of AX went second. And now I don't know why this is. I thought I moved. Anyway, the first one came out okay. So basically, we're a little endian. I wonder why that failed. RBF. Probably my program was wrong. Enter. No. 3344. One of 2. Good. Okay. So therefore, oh no. Oh, I was writing out the codes. Oh, I see. I'm not writing out. Anyway, it doesn't matter. The point is that part of that code included the number 3344, and that turned out backwards. I wasn't writing out the data. I was writing out the instruction codes. No wonder it was messed up. So that means that Unicode does not come to the rescue and save us, because the ordering of the high byte and the low byte of these word values that you've been writing out as strings to your file depends on what kind of machine is going to read it. If it's this kind of machine, then it's not going to read it right if it's the wrong direction. And sometimes there's no direction given at all. There's a thing in command here. How much time have I used? Well, it doesn't matter. You should know this. This still work? Okay, now here's that Intel doc, okay? Doesn't work under Notepad. I mean, it opens, but it's a mess. But if I edit, it's fine, right? It's the right code page. Now, if you do command/u, now I've launched a second instance of command. If I exit, I won't exit command. See, I'm back to where I was. So I'm going to go back again. In this mode, the internal piping commands are in Unicode. Okay, so watch this. Type intel dot blah 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 into, and I'll call this Unicode. Okay, so now we got a Unicode version. See, it's twice as big. Now we'll just open that up in here. No problem. Unicode open. Now that's odd. It put me into Notepad. Well, it's certainly displaying properly in Notepad, and that's one improvement. Right? But how come it's not opening it in here? How about if I just try and open it with the editor with encoding, maybe. Maybe that should work. Auto detect. Okay, why not? Normalize line endings. I don't remember changing anything, but I guess so. It says it's supposed to. Now what is this? Look what it's given me. It's all like double space. And what about where are those line things? Now it's this 20% sign. It's not correct at all. It's a mess. Worked under Notepad. How come it couldn't figure it out? I'll show you why. And I'll show you how to fix it. Open it with binary. You see this here? Well, the first two characters are a character return and a line feed in the correct order. Now ask yourself, is this little n first or big N first? A D character, okay, is the number in terms of if it were a word value. What can I write something down? Right? As a word, it's just that, okay? Now, the little n is this one. The little n is first. So our auto detector should have auto-detected that this was Unicode little n first, right? And translated that into a D character, but it didn't. Now, how do you deal with that? Now, I haven't even run this experiment, but I know it's got to work. Unicode, because it's not the answer, because it requires an extra step, where either you got to figure it out by trial and error, can a file that is encoded in wide character bits can have, going along with it, what's called a BOM. BOM. Byte Order Marker. Okay? Now for Unicode, the BOM is that. Okay? Now how does that make any sense? That means if you read in 2 bytes and translate that to a word on your machine and it says FEFF, then that means that the byte order of the byte of words in that file are in the same order as on your machine. However, if you get an FFFE, that means they're reversed. It doesn't matter if it's big N or little n, you got to reverse the bytes if you get this. Right? Everything's backwards with respect to your machine. It's got to be an FEFF. In order to turn that first word into an FEFF, you've got to reverse the bytes. So therefore, that's how it works. So now, what I know my machine's little endian, and I know this is little endian. So if I put a FFFE at the front of that file, when this thing reads it in, okay, it's going to translate that into a 16-bit value and get FEFF, meaning that this is in the same byte order as my machine, little endian, but it doesn't have to know that, and it should be able to read the rest. I'm going to save this, and I'm going to try and open it. I don't know if it will. It better not put a notepad. Open. Damn yeah. See? All right. It's correctly interpreted the file in Unicode. Now I don't know why it changed some character turn line speeds, but it did. Now that's okay. That's fine, right? Let me just redo that completely again. Am I still in the U? No. Command/U. Type Unicode. Okay. No problem. Now, what I'm going to do, even though I've got the code to do it myself on here, I'll use a special editor. This editor, Notepad++, which correctly has decoded it. No problems. The guy's got a brain. Now what I'm going to do is I'm going to save this as something else. UTF-8, not without, with. It doesn't have a byte or order. Okay, UTF-8 is a multi-byte format. However, if there's a 3-character sequence, this is an oxymoron. There is no byte order in UTF-8. The byte order is always the same. The only question is whether or not you want the header, the UTF-8 header. and I want that. So by that, I'll save as UTF-8. It already exists. Where am I saving to? I want to save where I came from. Alright, let's make sure that worked out correctly. Okay, it's quite a bit smaller than the other, now what I'm going to do is just, now I can't use the debug program unless I change this into a short file name. But I want to see it in binary. Well, I can still open it in binary. What didn't I save that? Anyway. Open in binary. Okay, now there's a special 3-character sequence I told you about before, and I'll tell you more about that later. And now we want that. That indicates UTF-8. Okay, so that's good. Now the question is, what if I just try and open this file? Just, double click, no selection, nothing. Oh look, no problems with carriage terms or anything. I wonder about the, oh look, the box is fine and everything's perfect. Why is everything perfect? Because there's no byte ordering issue with UTF-8. You see, UTF-8 is an algorithm, which I have explicitly spelled out here. For converting characters into a special format so that you can encode all characters from 0 up to FFFF, except for FEFF or FFFE. Those aren't allowed. Those are illegal. And this is the algorithm, and maybe you could hit print screen and try and work this out. You'll notice that this sequence, which is the sequence that tells you that something is UTF-8, would be a UTF-8 encoded FEFF. See? If you take FEFF, follow this encoding algorithm, you get this output, which is EFBBBF. Okay? And the algorithm is quite simple. But what is produced from it? To encode a value, you pass in a wide character, that is a 16-bit value, okay? A number. It could be 0x1234 or something, okay? Then you get 3 bytes of output, possibly. You might get 1 byte of output. Depends on what's inputted and the way this function returns. It tells you how many bytes of these were filled in. Okay, so that means it takes a regular 16-bit value and converts it to some sequence of bytes. Okay, of single bytes. To decode, you read in bytes, okay? So now that's here n size of string. I'm passing a pointer to a byte, my input stream, and what does it return? Okay, so here's my byte stream passed in. This here is the total size of the stream. This says don't read beyond that from starting from here. The return code, the return value is a 16-bit number. No endian backwards or forwardness. It doesn't matter how you go about reading or writing, the format is the same, no matter which machine you're reading in from or writing to, the format is exactly the same. So I'm sorry to say to Mr. Petzold that Unicode is not the answer. The answer is UTF-8, which is called the Universal Text Format. And you'll notice that web pages, any web page, I don't know if it'll show it here, they're all encoded in UTF-8. It's because it's the only way to do it. View page source. Anything that's not, ANSI is encoded in UTF-8. There's no Unicode on the internet. Doc type, blah blah blah. Well, it doesn't say. It's probably just assumed UTF-8. Language N. Well, maybe I'll try something with a different language. So Japanese. Actually, I know exactly where to go. Somebody sent me a message. With a video. Is it this one? This guy wants to rewrite Sonic the Hedgehog. Does this have non-English on it? No. No good. Well, I know that YouTube has lots of videos that are not English. Well, this guy's page. Look at that funny broken L he's got. This is not English, right? Now let's see what this says. View. See, it can translate. Come on. Language M. ID. Well, it can't be. No, it's not English. I don't know where it indicates how it's doing the translating of all those funny characters. But it's not, these things are auto-generated things, and they're included. In fact, the way to look at this is not with the source editor, but with this thing. You look at resources, styles. And somewhere in here, it's going to show you how it does the encoding. And you can be sure it's going to be UTF-8 somewhere. But I don't know where. God knows. Anchor, proto, native, athlete's body. Oh, there it is. There it is. Character set UTF-8. See? See? That's what they use. There's no Unicode anywhere. Unicode did not save the day. And it never will. It never will because of that problem, that constant problem that is always coming up. Is it little n first or big N first? I even have code in some of that other project where sometimes you're not given a byte ordering in a Unicode file, and I just try to make my best guess. I look for spaces. You look for space characters, which is 20, should be 020 or 20. It turns out 20 is invalid. Well, if you find 20, okay, either it's invalid, either it's big N first, or opposite Endianness, or it might be a phishing site. Apparently phishing sites use the character 2000 hex as a space type of invisible space character, so that they can copy another page that's visually identical but the actual data is different. Anyway, so that's a brief introduction to Unicode, UTF-8, and all that. Just remember, stick to UTF-8. Do everything in UTF-8. If you're not using Unicode characters like this, then everything's going to be the same as ANSI. If you are, it'll be taken care of, and it will be readable by any editor, even the idiot compiler. Okay, now I don't know what to do next, but I have a few ideas. See you.